Hello and welcome everybody. Hopefully everyone's having a fantastic day so far. Just before we start the notes here, we have this bell ringer, so if you've not had the chance to try it, make sure you do so. The sub may have to pause this video to give you a chance to try it. If everyone's given these problems a good try, we can go ahead and kind of talk through them together. So looking at the first one, we have these different expressions. It says rewrite the following as a sum or difference. And remember from last lesson, there's two ways we can do this. The first way is we can rewrite this expression as 1/8 times 2x plus 5. And then from there, you can just go ahead and do the distributive property that we learned last lesson. We also talked about a little bit easier way to simplify this fraction from yesterday's lesson. We said, well, instead of doing that, an easier way to think about it is just take the 2x divided by 8 plus 5 divided by 8. And we could have just done those fancy arrows, which gives us 2x over 8 plus 5 over 8. Which we can do a little bit more simplifying because we should notice that 2 divided by 8, that's going to simplify to 1x over 8, right? 2/8, not over 8, sorry, over 4, my mistake, because 2/8 will simplify to 1/4 if we divide each of them by 2. So 1x over 4 plus 5 over 8. The question you should be asking yourself, do we have to have that 1 in front of the x? And no, you do not. It would be fine if you also had x over 4. This next one here is just another, looks like distributive property problem. What gives it away that it's distributive property is that parentheses there. So we know we have to take this -3 on the outside and we have to distribute it to all three terms, the x, the 5, and the y. So if we take -3 times x first off, that's going to give us a -3x. Next we have to take a -3 times 5, positive 5, so that gives us -15. And then lastly, we have to take a -3 times a -y. We should know that a negative times a negative is a positive, so we get a positive 3y. And that was review from yesterday. This last one here, this is something I saw on social media a year or two ago, and it says only for geniuses. So they put this math problem on there, and then there's people commenting what they thought it was, and there's so many people with so many different answers. However, we should know that using PEMDAS, we can find the right answer pretty quickly. The problem arose was on social media, a lot of people just went from left to right, which we know we cannot do. So if we think of PEMDAS, we know the P stands for parentheses, there's no parentheses there to work or to simplify. E stands for exponents, again, no exponents. And then we come to the M and the D, multiplication and division. Remember, just because M comes first in PEMDAS, that doesn't mean that we always do that first. It just means if both are in the problem, we have to do whatever comes first when we're thinking left to right, just like if we were reading. Here in this particular problem, we just see the multiplication. So that's what we have to do first. So we still have this 3 minus 3 times 6 gives me 18 plus 2. Alright, so now we're getting to the A and S part of PEMDAS, addition and subtraction. Remember, just like multiplication and division, you just have to do whichever one comes first in the problem. So just going left to right. So that means we have to take 3 minus 18 first. And 3 minus 18 is a -15 plus 2. So -15 plus 2 is a -13. So that's what you would have posted on that social media comment section if you saw this problem. Just using PEMDAS, you should have done -13. All right, hopefully that review went okay for you. What we're going to talk about today is an idea called combining like terms. We do this idea of combining like terms so that we can simplify expressions or make them look nicer in the end. Essentially, what we're doing when we're combining like terms is we're just combining terms that look alike. That's why I put the pictures of these twins here. In order to combine terms, they must have terms, or they must be terms that look alike. So that's going to be our goal today. We're going to see if we can determine like terms and non-like terms, and we're going to simplify expressions. So to combine like terms, that means we must add together items that are the same to make a simplified, shorter list of items. Again, just to kind of clean things up, make them look nicer in the end. So here's just a super basic example of combining like terms. So if I asked you to combine like terms with this problem here that talks about cheeseburgers, fries, and it looks like pop, you would think, well, what would be considered a like term with these 2 cheeseburgers? Well, obviously it would be these 3 cheeseburgers. So if I were to combine those in the end, I would have 5 cheeseburgers. Plus, obviously next here I see fries. I can't combine fries with burgers because those are 2 totally different things. So if I was making an order, I'd say, well, I want 5 cheeseburgers and I have 1 fry. Looks like I have 2 fries over here. So if I combine those like terms, I'd have 3 fries. And then lastly, if I look at the pop, I have 1 pop here again, and 2 pops over here. Oops. So that means I'd have plus 3 pops. And that's essentially all we are going to do when we combine like terms. We're going to look for things that are the same. Before we get into some actual examples of combining like terms, there's a few vocab words that we have to be familiar with. So the words to know. The first one is a term, and you've heard me use this a lot. You've probably heard a lot of other of your previous math teachers talk about terms a lot. You may not have always understood what a term is. So let's just clarify here so we're all on the same page. A term is a number. So for instance, an example would just be the number 3. It's a number. It could be a variable, and a variable is just a letter that represents one or more numbers that may be unknown to us at this time. So variable is just some letter, or the product of a number and a variable. So when we say product of a number and a variable, that's talking about multiplication. So you might see things like 3x or 5x. Those are all examples of terms. One thing to add here, which I would add to my notes to help clarify, terms are separated by an addition or subtraction symbol. So for instance, if I gave you this expression here, I said 3x plus 2, I would ask how many terms are there, and you should say that there are 2 terms. There's a term of 3x and a term of 2. Okay, 2 terms in that problem. Second vocabulary word is variable, which I just talked about a little bit. Again, though, it's just a symbol, usually a letter that represents one or more numbers. Really, you can use any letters that you want. Most commonly, you're probably going to see the letters X, Y, and even Z in problems. Ones to avoid, I would probably avoid an S, which because an S can oftentimes get a 5 depending on how messy your handwriting is. And I'd also avoid the L, right? Because an L can look like a 1. Unless you do kind of a cursive L, then that would be okay. Next term here is a constant. A constant is a number with no variable. So constants are just things like 1, 2, 10, 30, and so on. just numbers, no variables. That's what we would refer to as a constant. And then finally, a coefficient is a numerical factor in a term that tells us how much. So the coefficient is your number in front of your variable. So for instance, if I had 3x as my term, my coefficient then, it's underlined in orange since that's what we're talking about, the coefficient is the number 3. So it tells me I have 3 x's. Just like over here on our last example, when I had 5 cheeseburgers, 5 is the coefficient. It tells me how many I have. So in this example here, it's going to deal with some of that vocab word. It says identify the terms, constants, and coefficients. So let's go ahead and start with the terms. Think to yourself, before I talk about this problem, how many terms do you see up here? You should be thinking to yourself, I see 3 terms. So remember again, terms are separated by an addition or subtraction sign. So here's 1 term, 2 terms, 3 terms, 4 terms. So we have a positive 6a squared. The 5ab, that is negative, so we got to make sure we put a negative sign there, negative 5ab. Next we have the 3b, that's my 3rd term, and last term is a negative 12. Those are my 4 terms. Next thing they want us to identify, they want us to identify a constant. Oopsie, I'm going to switch colors here. Constant. Thinking back to our vocab on the other page, remember a constant is just a number with no variables. So if we look up here for a number with no variables, 6a squared wouldn't work, 5ab, nope, 3b, nope. But this negative 12 has no variables. So that is my constant term. And last but definitely not least, let's talk about those coefficients. Remember, coefficients are numbers in front of our variables that tell us how many. So looking at this first term, 6a squared, 6 would be the coefficient because it tells us how many a squareds we have. And the next one, negative 5ab tells us we have negative 5 of those ab's. So negative 5 is our coefficient there. 3b tells us we have 3 b's. So 3 is our coefficient. And constants don't have coefficients, so we don't have to worry about that there. All right, hopefully those vocab words are making sense to you. All right, so now we're going to get into some problems where we are actually combining like terms. But before we can do that, we have to understand what makes 2 terms considered like terms. So it says here in mathematics, we can only combine things that are like terms. This means in order to, what we're going to add here is add or subtract 2 things, they must have the same variable. It means they have to have the same letter, and they have to be raised to the same power. Or in other words, they just must look alike. So a quick example here. Let's say I gave you these terms, 3x and 5x. And I asked you, are those like terms? You would go ahead and answer yes, because they have the same variable, they both have x's, and both of those x's are actually raised to the same power, right? There's no power we see there, but if there's nothing there, we assume it's a 1. So they're both raised to the first power. So yes, those would be considered like terms. On the other hand, if I gave you, let's say 3x squared and 3x, and asked you if those were like terms, you would go ahead and answer no. They do have the same variable, right? They both have the x there. However, those x's are not raised to the same power. This one is raised to a 2. This one is raised just to a 1. So these are not like terms.